So today we're going to be talking about artificial intelligence. This is going to be start to a new series on machine learning on this channel. So we're specifically going to be focusing a lot on neural networks, but we might dabble into some other forms of machine learning, such as just linear models, that sort of thing. But today's video is going to be more of an introduction to AI, what it is, what it can do, and what it can't do. So firstly, when we're talking about artificial intelligence, what do we mean by that? Well, a generally accepted definition is that artificial intelligence is a computer program that can do any sort of intellectual task. And here's a few examples we have here. So we have, self-driving vehicles, playing chess or Go or any board game for that matter. But there's also more sort of nuanced and more complicated intellectual tasks, such as recognizing faces or parsing words out of audio from what someone is saying and turning it into text. And we're also seeing more advanced forms, such as writing news articles, making pictures and art and music. And these more sort of output tasks rather than input tasks, just learning to recognize faces. Now we're actually creating something new and novel. So there's been a lot of progress in the field of artificial intelligence, especially with neural networks in the past 5 years. So most of what I just talked about were actually done by neural networks, and it's a special kind of machine learning. So if we go down here, we can sort of look at the different forms of AI. And AI has several different categories, but the important one here is machine learning. Now, machine learning has actually only been relatively new. It wasn't adopted for most of AI's history for the 60s and 70s because computer hardware just wasn't there, and we also didn't have these large data sets available to us, because what we were doing before was something called symbolic AI. And this is something where you would essentially just give a computer a very long and complicated list of instructions that you wrote yourself, and that's how it would accomplish its task. And we saw this in Garry Kasparov versus Deep Blue. That was symbolic AI. It was a bunch of chess masters and programmers got together and created a very sophisticated set of rules to program this computer to defeat Garry Kasparov. And that's mostly how AI went for a very long time. However, there are certain tasks, such as perhaps recognizing handwritten digits or parsing words from audio, that it's not very clear how you would go about writing rules in order to do that. That's a very complicated task. So instead, what we would do is we have this new form of artificial intelligence that's really taken off, called machine learning, where we don't explicitly state the rules. Instead, we give the machine some examples, or maybe we don't, depending on the type of machine learning, and it sort of learns the rules itself. So this required a lot of computing power, and also usually required a lot of examples, a lot of data. And that was something we usually didn't have available to us until recently. So as you can see, this is sort of how machine learning has changed the paradigm. With traditional programming at the top, we have rules that we write, and we get inputs and we get answers. But with machine learning, we don't know the rules, so we just have inputs, answers, and we get the rules through machine learning. And neural networks and deep learning in general is a special kind of machine learning. There's other more simple forms of machine learning that aren't as complicated, don't require as much data or computing power, and these were dominant as well up until about the mid-2000s, in which neural networks, we finally eclipsed the sort of computational barrier, the hardware ceiling that we had put ourselves in. So this is very new stuff right here. So this is the main difference between traditional programming and machine learning, is that now instead of making the rules, you're discovering the rules, and you can sort of teach the computer to do things itself given enough data and computational power. So in this series, we're going to be covering a few different kinds of artificial intelligence. As you can sort of group artificial intelligence in several ways. The most straightforward and simple one we'll be covering at first is supervised learning. And this is the most basic you could imagine. You give the artificial intelligence some input and you tell it what the output should be. So here you have this function. You can look at the function. And what do you think the general rule for this function is? And hopefully the AI can deduce that would just be x squared. So we call these labeled inputs, and we'll get more into the jargon and sort of technical terms next video, but these are labeled inputs. You give them a label of what the output should be, and this sort of infers a function, what the function could be to produce this output. And this is pretty common for classification problems, regression problems, where you're trying to find a specific number. So say you're given a series of descriptors about a house and you want to find its price. That would be a regression problem. And classification problems are you're trying to fit something into a class. So you want to classify a face as, say, male or female, or something along those lines. Next, we have unsupervised learning, which clusters data points together into groups. We won't talk about this as much. There's a lot of applications to it, but it's a little bit more complicated. And then we have semi-supervised learning, where you basically just give examples to groups. Like, you say you have one data point, you say, okay, this is part of this group right here, and then it can figure out which other data points are in that group. Again, we won't be talking about that a ton. Additionally, we also have batch learning versus online learning. So batch learning is sort of an older technique. It's not as used as it once was. You're given a bunch of inputs, and the machine model will learn from these inputs, and then you can use the model, and that's it. You can't update it with new examples. You'd have to start from scratch, essentially. And then we have online learning. And online learning is a bit of a misnomer. You don't actually have to be connected to the internet in order to do it, where essentially you can train the model using a series of inputs, and you can start using the model. But if you get new inputs or you want to train it some more, you can use that same model and just iterate upon it. So that was a basic overview of the sort of fields of AI that we're going to be talking about. Very exciting field. I'll be getting into examples, showing you how you can use it yourself. We'll mostly be using the TensorFlow library, although we'll use a few others as well. And I'm pretty excited about this series. It's going to be pretty epic, so stay tuned.